present lecture, we will discuss on the problems related to the Bernoulli's equation and its applications. You know, the Bernoulli's equation is nothing but the energy equation, which states that for a steady, incompressible fluid, irrotational flow, non-viscous fluid, the total energy remains as constant. The total energy is nothing but the pressure head plus the velocity head plus the datum head is equal to constant. The first term, pressure head, is also called as the pressure energy per unit weight of the fluid. The second term, velocity head, is called as kinetic energy per unit weight of fluid. And the third term, datum head, is called as the potential energy per unit weight of fluid. So the summation of the pressure energy, then kinetic energy, then the potential energy per unit weight of fluid is constant. So if you are asked to calculate what is the total energy of the fluid flow, then you need to calculate what is the pressure head, what is the velocity head, what is the datum head, sum up, then that gives you the total energy. The second type of problem is if the Bernoulli's equation is applied between 2 points, then how to apply the Bernoulli's equation? So the Bernoulli's equation at point 1 is P1 by gamma plus V1 squared by 2G plus Z1 is equal to, at the second point, P2 by gamma plus V2 squared by 2G plus Z2. If there are no losses, automatically P1 by gamma plus V1 squared by 2G plus Z1 must be equal to P2 by gamma plus V2 squared by 2G plus Z2. This is the Bernoulli's equation applicable to 2 points in a pipeline. Right. Next, third point. The question may be, what is the loss of head between the two sections? When the question is what is the loss of head between the two sections means calculate the total energy at section 1, calculate the total energy at section 2, then see which is higher, and then higher minus lower is nothing but the loss of head. Then there is another question which can be asked is what is the direction of flow? Please remember that the flow direction will be always from a higher energy to a lower energy. Suppose if they ask at point A, they have given you pressure, velocity, and datum. At point B, they have given pressure, velocity, datum. So calculate the energy at section A. Calculate the energy at section B. Then see which is higher. If suppose the energy at A is higher, that means flow is taking place from A to B. Or if the flow energy at B is higher, then flow is taking place from B to A. So this is one type of question. So you remember the Bernoulli's equation is applicable to infinite number of the problems which we face in everyday life, whether it is basically pumping the water from a sump to the overhead tank, or whether it is supplying water from a hill bottom to the hilltop, or whether the flow is taking place from one village to one town to another town, or wherever the flow is taking place, we need the application of the Bernoulli's equation in order to get actually number one is the what is the flow at any, what is the energy at any point, number one. Number two, what is the loss of energy, number two. Number three is what is the direction of flow. Number four is what is the capacity of the pump that is required to pump the water from a sump to the overhead tank. So all these problems, the application of Bernoulli's equation is necessary. So let us solve some problems in this direction and then take ahead. So straight away I will share with you the whiteboard. So let us take straight away the problem of the application of the Bernoulli's equation. A 0.25 meter diameter pipe carries oil of specific gravity 0.8 at the rate of 1 liter 120 liters per second, and the pressure at a point A is 19.62 kilonewton per meter square. If the point A is 3.5 meters above datum line, calculate total energy at point A in meters of oil. This problem is mainly intended to really drive you on how to calculate the or how to use the Bernoulli's equation in practice. So, for example, you take it now. The diameter of the pipe D is equal to 0.25 meters. The second one is oil of specific gravity. He has given it as zero point 0.8. It is not water; it is oil basically. And then rate of flow is Q is equal to 120 liters per second. So immediately that liters per second is equal to, you have to convert into meter cube. You know that 1000 liters is equal to 1 meter cube. So convert it immediately. So 120 into 10 to the power of minus 3 meter cube per second immediately. Then the pressure at a point A is equal to, he has given PA is equal to how much? 19.62 kilonewton per meter square, right? That is fine. So then if the point A is 3.5 meters above, so that means Z is equal to the datum which we represent. ZA is equal to, he has given 3.5 meters. Right, now let us go one by one. So how to calculate P he has given anyhow. So let us first calculate the velocity. So velocity, how you will get velocity? You can get only by using continuity equation, Q by A. So Q is equal to 120 into 10 to the power of minus 3 divided by pi by 4 into A is 0.25 whole square, where 0.25 is the diameter of the pipe. So if you calculate that velocity, you will get it automatically from 2.45 meters per second. This is the first step. Once velocity is known, then let us go into the Bernoulli's equation. What is the Bernoulli's equation? It is P by gamma plus V squared by 2G plus Z. This is the total energy. That is what the question. This total energy is constant, is the Bernoulli's equation. So total. Now P by gamma, what P is actually in Newton per meter square we have to put. Gamma is the specific weight of the oil. So let us take first P by gamma. How to write? P by gamma is P is equal to, he has given it as 19.62 kilonewton per meter square. So if I convert into Newton per meter square, it is into 10 to the power of 3 newtons per meter square. That is P in the numerator. Then gamma we want. What is gamma? Specific weight of oil. Specific weight of oil, how we will get? Specific gravity multiplied by the specific weight of water. Specific weight of water is 9810 Newton per meter cube. So if you do it, then automatically you are going to get in meters basically. So what is, how much it is that? If you calculate it, you are going to get 2.5 meters of oil. This is the thing. So P by gamma is what? What is V square by 2G? Already V I calculated. V is 2.45 whole square divided by 2 into 9.81. So it comes how much actually? It is 0.31 meters of oil actually. So this is the second one. Then what is Z he has given? Z is equal to 3.5 meters. So now total energy is how much actually? The total energy is equal to P by gamma plus V squared by 2G plus Z. So that is P by gamma is how much? 2.5 plus what is V squared by 2G? 0.31 plus what is Z is equal to 3.5. So it is equal to 6.31 meters of oil. Then let me go into the second problem. A 0.3 meters pipe carries water at a velocity 24.4 meters per second. At points A and B, measurements of pressure and elevation. Elevation is nothing but datum. Elevation were respectively 361 kilonewton per meter square and 288 kilonewton per meter square. And the elevations are 30.5 meters and 33.5 meters. For steady flow, find the loss of head between A and B. This is what I mentioned in my earlier introductory remarks. So now we will take it actually. The diameter of the pipe is constant. So diameter of the pipe is 0.3 meters. So when once the diameter is known, you can calculate the area. Then he has given velocity and the velocity because diameter is constant, automatically the velocity is also constant. V is equal to 24.4 meters per second. Now point is for example, this is the pipe. So write this is section A and this is section B. So now the pipe diameter is constant, then velocity is constant. Then what is the pressure actually? Pressure here he has taken it as 361 kilonewton per meter square, whereas here it is 288 kilonewton per meter square. And date elevation survey, what is the elevation actually? Here Z is equal to 30.5 and here meters, here that is equal to 33.5 meters. The meaning is the B is at higher level, at higher level, right? A is at lower level. That's what this is not horizontal. Actually, it should be the pipe should be like this actually. So if you take it, it is A, it is B, right? Now you take this as datum. This is the center line of the pipe. Now naturally this is what we call it as 30.5 and this is what we call it as basically 33.5, right? Pressure is already noted. So this is how, what is his question? What is the head loss between A and B? What is the head loss between A and B? How much? This is the question. So now what I will do, I calculate the total energy at A, I calculate the total energy at B, then I will see which is higher and I subtract from higher to lower one, then I will say what is the loss of head. So now what is the total energy basically at any point action, total energy at any point is equal to P by gamma plus V squared by 2G plus Z. This is the general equation for us. for total energy at any point. So now I will do what is Pa by gamma. Pa by gamma is how much? He has given it as 361 kilonewton per meter square into 10 to the power of 3 Newton per meter square. So this is first one. Gamma is what is flowing? Water is flowing. So what is this? 9810 Newton per meter cube. So if you see it, how much it is coming? 36.80 meters of what? Meters of water, because that meters means you should write what is the fluid also, so that is very important. Then what is the v squared by 2g? Because velocity is given, so we will calculate va squared by 2g. V is how much he has given? 24.4. 24.4 whole square divided by 2 into 9.81, so that amounts to 30.34. It is again meters basically of water, whatever fluid it is flowing. Then next, ZA is equal to how much he has given? ZA is equal to 30.5. So it is equal to 30.5 meters of water. So finally, total how much it is? That is Pa by gamma plus Va square by 2g plus ZA is equal to total energy at how much? It is 36.80 plus 30.34 plus 30.5, and it sums up to 97.64 meters. So for 1 point is what. Now let us do the same thing at B. What is PB? P by gamma. PB is how much he has given? He has given 288 kilonewton per meter square. So 288 into 10 to the power of 3 Newton per meter square divided by gamma is how much? 9810 Newton per meter cube. So that sums around to how much? 29.36 meters of oil. That is, then VB squared by 2g, how much? It is exactly whatever previously it is there, the same thing, because velocity did not change from point A to point B. So it is 30.34 meters of oil, like whatever velocity is there at A. Then what is ZB? ZB is changing. He has given ZB is equal to 33.5 meters. So naturally, now we put sum it up. Actually, Pb by gamma plus Vb squared by 2g plus Zb is equal to. So now if I sum it up, 29.36 plus 30.34 plus 33.5, it is equal to total how much it is coming? 93.20. That means where the head is more at A, at the head at A, the head at A is higher, right? So therefore, loss of head is equal to 97.64 minus 93.20. So it is equal to 4.44 meters. And what is the direction of flow? The direction of flow is, what is the direction of flow? Direction of flow is always from in higher head to lower head, higher energy to lower energy. So therefore it is flow is from A to B. So this completes the second problem. Let us take one more problem here. Water is flowing through a pipe having diameters 20 centimeters and 10 centimeters at sections 1 and 2 respectively. The rate of flow through pipe is 35 liters per second. The section 1 is 6 meters above datum, and section 2 4 meters above datum. If the pressure at section 1 if the pressure at section 1 is 39.24 Newton per centimeter square, find pressure at section 2. Water is flowing through a pipe of diameters actually 20 centimeters and 10 centimeters at section 1 and section 2. Rate of flow through the pipe 35 liters per second. Section A is 6 meters above and section 2 is 4 meters above. That means section A1 is higher, section 2 is lower. If the pressure at section 1 is 39.24, what is the pressure? So if I draw the diagram actually, suppose you take the thing. So now this is pipe diameters are also changing actually. So at one place, this is the first section. If I write, this is the second section. So at the first section it is 20 centimeters, and at this second section it is 10 centimeters, right? Now this is, I call it as section 1, and this I section 2. Now if I draw a reference line, so this is datum line is 6 meters, this is 4 meters. So first we should see whether the pipe is horizontal, inclined, whether the pipe is what you call it as same diameter, or some tapering is there, diameters are changing. So these are all the things first you need to understand from the problem. Right now, I don't know whether the direction of flow is from 1 to 2 or 2 to 1, but only what I can write it is the pressure at section 1 is equal to, he has given it as 39.24 Newton per centimeter square. So these are all the things that he has given. Now what is he has given? Q also he has given. Q is equal to 35 liters per second. So now the data has come into the picture. So drawing the figure is very, very vital while solving the problem, because it makes the problem very easy, because the equation is only one, that is P by gamma plus V squared by 2G plus Z. So this is the equation. So but the understanding of the problem is very, very important in Bernoulli's equation to apply that action. So this is the thing. Now let me calculate. So first he has given P1 is equal to 39.24 Newton per centimeter square. So automatically I want for Newton per meter square, because the unit that which we are following is Newton per meter square. So it is 39.24 into 10 to the power of 4 Newton per meter square. So that is over. Similarly, Q is also in another units, that is 35 liters per second. We don't want liters per second, we want meter cube per second. So it is 35 into 10 to the power of minus 3 meter cube per second, as 1 liter is equal 1000, 1 meter cube is equal to 1000 liters. So these two were over. Then naturally, next thing for me is what is the velocity at section 1, what is the velocity at section 2. So we know, use the continuity equation. Q is equal to a1 v1, which is also equal to a2 v2. So now v1 is equal to q by a1 and v2 is equal to q by a2. So Q is already known for us, that is 35 into 10 to the power of minus 3 by area at 1 is equal to, he has given 20 centimeters. So pi by 4 into 20 centimeters he has given. So convert into meters, actually it is 0.2 whole square. So if you can get it, it will be velocity at section 1 will be 1.114 meters per second. Similarly, here 35 into 10 to the power of minus 3 divided by area is pi by 4 into 0.1. because 10 centimeters. So whole square, which is equal to 4.456 meters per second. So velocity also we got it. Pressure at section 1 known, velocity 1. And already he has given Z1 is equal to 6 meters, Z2 is equal to 4 meters. Now apply Bernoulli's equation. Bernoulli's equation is what? P1 by gamma plus V1 squared by 2G plus Z1 is equal to P2 by gamma plus V2 squared by 2G plus Z2. This is what the Bernoulli's equation. So now what is P1 by gamma? P1 by gamma is equal to 39.24 into 10 to the power of 4, which already we have done, divided by gamma is equal to 9810, right? Plus what is V1 actually? 1.114 V1 square by 2 into 9.81. This is next. Plus Z1 is how much? 6. It is equal to P2 by gamma, which is unknown. V2 squared by 2G is what? 4.456 square divided by 2 into 9.81 plus basically Z2 is what? How much? So therefore calculate P2. P2 is equal to, now if you P2 by, if you calculate P2 by gamma is equal to how much you are getting, it is getting some approximately 41.051. So if you get point, then what is P2 is equal to 41.051 into gamma. Gamma is how much? 9810. If you put all these things, then automatically you are going to get uh, 40.27 Newton per centimeter square. Otherwise, 40 this much into this is Newton per meter square. I converted into Newton per centimeter square. So here we will stop with the first three problems, and let us take some more problems in the next class. Thank you so much.
Like, share, and subscribe. Hit the bell icon for more updates.